Welcome to Einstein's Mechanics. In this episode, we are going to solve second example on the Gaussian elimination method. Now, the question says, solve the system of equations using Gaussian elimination method. So we have equation 1, equation 2, and equation 3. So straightforward, you are going to write your matrix from the equation. I'll call it A. So my matrix from equation 1, my x part is 1 and my y is also 1. The z is negative 1 and that is equal to 9. Okay, so let me just write the matrix for the first part, then after we combine it, then we bring the 9. So for the second equation, I'm going to get, there is no x, so that's 0. For the y, that is going to be 1, and the z is going to be 3. The third equation, that is a negative 1, there is no y, so 0 and negative 2 for the z. So this is my matrix from the equation. From the equation, my c part is also going to be equation 1 is equal to 9. Equation 2 is equal to 3 and equation 3 is equal to 2. Are we okay? So now that we have it this way, now pay attention in order not to interchange your writings. This first row represents equation 1 and that is equal to 9. The second row is equation 2 which is equal to 3. This third row is equation 3 which is equal to 2. Pay attention in order not to exchange them. Are you okay? That will give you a wrong answer. So now that I have this, I can go ahead and write my A combined with the C, which is going to give me this matrix 1, 1, negative 1. And the C for the first row is 9. This is 0, 1, 3. This is 3. And negative 1, 0, negative 2. This is 2. I have to now apply the rule principles to convert everything on the principal diagonal to 1 and everything below it to 0. This is quite easy because we can see that most of them are already 0 and we can do it straightforward. So this is already 0, this is already 0. We have to convert this negative 1 to positive or something 0 and convert this negative 2 to 1. That would be very simple. So this is the matrix. So what do? I want to convert this negative 1 to 0. I can add equation or row 3 and row 1. So my first thing is going to happen on row 3, which is going to be row 1 plus row 3. Meaning row 1 is going to be the same 1, 1, negative 1 by 9. Row 2, that will be 0, 1, 3 by 3. So for row 3, this is 1 plus negative 1. That will be 0. This is 1 plus 0. And here is going to be 1. This is negative 1 plus negative 2. And this is going to be negative 3. 9 plus 2. And this is going to give me 11 for this part. So now I have this. I also want to turn this part to 0 because it has to be 0 so that this principal diagonal will be 1. So now I'll apply another rule to row 3, which says row 2 minus row 3. Meaning row 1 is still the same 1, 1, negative 1 by 9. Row 2, 0, 1, 3 by 3. So row 2 row 2 by row 3. So 1 minus 1. Here is 0 minus 0. So we have our 0. The 1 by 1, which is also 0. 3 minus minus 3. That is going to give me positive 6. And 3 minus 11, negative 8 for that. What's left? I have to now make this 6 to be positive 1 so that the rule will be obeyed. What do I have to do? I have to multiply equation or row 3 by 1 on 6. Row 3. Row 1 is 1, 1, negative 1, 9. Row 2, 0, 1, 3. So 1 over 6 by 0 is 0, by 0 is 0, and by 6 is 1. So this is 3, and 1 on 6 by this negative 8 is negative 4 on 3. So now this is what we have. And yes, this is an upper triangular matrix. We have ones on the principal diagonal and zeros beneath it. So we've achieved what we want to achieve. Let's try to now find the x, y, and z from this now. So I can call the third row as my equation 3, the second row as my equation 2, and the first row as my equation 1. So now from here, I can say from equation 3, from the third row, I can write it as 0x plus 0y plus 1z, which is z, equal to negative 4 on 3. This means that our z, because the rest are 0, our z is equal to negative 4 on 3. Are we good? And now we can also consider equation 2, and from equation 2, which is the second row, we can write it as 0x plus y plus 3z equal to 3. Is that right? Yes. So now I know the value of z already. So can I say y is equal to 3 minus 3 times the z, where z is negative 4 on 3. And this is going to give me 7 for the y. Now from the first equation, equation 1, which is the first row, I can also write it as x plus y minus z equal to 9. This means x is equal to 9 minus y, where y is 7, plus z, where z is negative 4 on 3. When you solve this, your x is going to be 2 on 3. Meaning when you solve for this system of equation, your x is 2 on 3. Then your y is 7. Z is negative 4 on 3. So this is the solution for this system of equation using the Gaussian elimination method. Thank you for watching this episode. Subscribe to the channel and like the videos. Also, drop your comments and everything you need. Thank you.